Hello friends, welcome to our channel Knowledge Dhara. Today we are going to start class 9 physics chapter 3, that is gravitation. So let's start. Our first topic is what is gravitation? So the definition is an attractive non-contact force between any two bodies in the universe is called gravitation or gravitational force. Means the force of attraction or non-contact attractive force between any two bodies in the universe is called a gravitational force. So for example, the attractive force between the earth and the sun is the gravitational force between them. This was an example, so let's move ahead. So some examples of gravitation. So this is first example here, bungee jumping, and this is second example, that is showing the revolution of moon around earth, and this is emerging of tides. So we will study reason behind them. So bungee jumping due to the gravitational pull of the earth. Bungee jumping is done due to the gravitational pull of the earth. So the moon revolves around the earth due to the gravitational pull of the earth. The moon revolves around the earth due to the gravitational pull of the earth. Tides are formed due to the gravitational pull of the sun and the moon. So the tides are formed due to the gravitational force of sun and moon. So let's move ahead. So our next topic is what is Newton's universal law of gravitation. So we have to study this, and by this law we will get the formula of gravitational force. So let's study its definition. So Newton's universal law of gravitation states that each and every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of distance between them. So this is the universal law of gravitation given by Sir Isaac Newton. So Newton's universal law states that each and every body in the universe, means every body which has mass, attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of distance between them. So this gives us gravitational force proportional to mass 1 into mass 2. Also gravitational force proportional to 1 by distance square, or gravitational force inversely proportional to distance square. So this gives us gravitational force proportional to mass 1 into mass 2 by distance square, or we can write this as F proportional to m1 into m2 by r square. Here m and m1 and m2 is mass 1 and mass 2, and r square is distance square, and force is F means force. So force is equals to g m1 into m2 by r square. So this is the formula of gravitational force. So here g is gravitational constant. We will study further about gravitational constant, but here you have to learn this formula. F is equal to g1 into g. F is equal to g into m1 into m2 by r square. So this is the derivation of formula by Newton's universal law of gravitation. So let's move ahead. Now gravitational constant, this we have to study now, and first thing is that gravitational constant is denoted with capital G. So the definition is the gravitational constant is the gravitational force which acts between two objects in unit mass separated from each other by distance of 1 unit. Means gravitational constant is the gravitational force between two bodies of a definite mass, and these are separated with each other by distance of 1 unit, we can say like this. So the SI unit of gravitational constant is Newton meter square kg raised to the power minus 2, or we can say Newton meter square kg square per kg square. So the value of gravitational constant is G is equals to 6.67 into 10 to the power minus 11 Newton meter square per kg square. So this was gravitational constant. So let's move ahead. But before that, you have to learn this form value of gravitational constant, as this is important for the numericals of this chapter. So let's move ahead. Now, Kepler's law of planetary motion. This is important laws. Because of this laws only Newton was able to find that inverse square rule. So let's study what is Kepler's law of planetary motion. So the great German astronomer Johannes Kepler has given us 3 laws of planetary motion. So great German astronomer Johannes Kepler had given us 3 laws of planetary motion. So what are these laws? The planets move in elliptical orbits with the sun as one of the focal points of the ellipse. The line joining the sun and planet cover equal areas in equal interval of time. The cube of mean distance of a planet from the sun is proportional to the square of the orbital period. So this will give us r cube by t square is equals to constant. So this is the constant. So these are the 3 laws of Kepler's laws of planetary motion. Remember this, that this is a constant. You have to learn this. So let's move ahead. How did Newton guess the inverse square rule? So how Newton guessed the inverse square rule? Here we will study that. So Newton used Kepler's law of planetary motion to guess the inverse square rule. He did as follows. F is equals or F proportional to V square by R. This we know. F is the force on the planet, V is velocity of the planet in the orbit, and R is the radius of the orbit. So but velocity in circular motion is equals to 2 pi r by t. This we have studied in previous chapter, that in a circular motion velocity is 2 pi r by t, where t is the time period. So by squaring we will get v square proportional to r square by t square. So this we can write like this: v square proportional to r cube by r into t square. So we have already learned that in Kepler's third law of motion, that r cube by t square is a constant. As Kepler's third law of planetary motion, r by t square is a constant. So v square proportional to 1 by r. So therefore by using equation in 1, we get force is equals to 1 by r square. So by this Newton got the inverse square rule. So let's move ahead now. What is free fall? Our next topic is what is free fall. So the motion of a body towards the earth when only the gravitational force acts on it is called free fall. For example, bungee jumping, as we have seen before also. This is easy example of free fall. So our next topic is motion of particles under gravity. This is important. So Italian physicist Galileo Galilei found if there were no air, all the bodies having different masses when dropped would fall at the same velocity. So Italian physicist Galileo Galilei found that if there is no air, there is vacuum, so every body with different masses will fall down with same velocity. But by this we can conclude that the acceleration during the free fall does not depend on the mass of the object. Note this thing, that acceleration due to gravity do not depend on mass of an object. We will study what is acceleration due to gravity, but first note this, that acceleration due to gravity or during free fall does not depend on mass. So let's move ahead. Now acceleration due to gravity. Here we will study acceleration due to gravity. What is acceleration due to gravity? So let's start with definition. The acceleration produced in a free falling body due to the gravitational pull of the earth is called acceleration due to gravity. Means the acceleration produced in a free falling body. A free falling means a thing is dropped down, so the gravitational force is acting on it. So the acceleration then produced is called the acceleration due to gravity. It is denoted as g. Remember this, g is acceleration due to gravity. So acceleration due to gravity is a vector quantity. As acceleration is also a vector quantity, acceleration due to gravity is also a vector quantity. So SI unit of acceleration due to gravity is also meter per second square. Means this all are same as that of acceleration that we studied in first chapter, motion. So formula of acceleration due to gravity is G is equals to G m by r square. Here G is small g is acceleration due to gravity, capital G is gravitational constant, m is mass, and r square is distance square. So value of acceleration due to gravity on earth is 9.8 meter per second square. So value of acceleration due to gravity on earth is 9.8 meter per second square. One thing more, that gravity is not constant on earth everywhere. Means this is, imagine earth, so at poles the gravitational force is higher or highest, and at equators the gravitational force is lowest. So this is the equator, so on the equator the gravitational force will be the least, and at the poles the gravitational force will be the most, because earth is not fully circular in shape. Because due to that, means at equator the distance from earth center is more, so there the value of acceleration due to gravity will be also more. So let's move ahead. Equations of motion under gravity. So we have studied in first chapter 3 equations of motion, so we will make from this equations of motion under gravity. So firstly, equations of motion, we will recall what are the equations of motion. So v is equals to u plus at, s is equals to ut plus half at square, v square is equals to u square plus 2as, and this v plus is equals to u plus at, these all are equations of motion. So here we will make equations for freely moving object or freely falling object. So first equation will become this, v is equals to u plus gt. Here a acceleration will become acceleration due to gravity. Second, s is equals to ut plus half at square. So here it will become, s will become height. So displacement will become height, ut will remain same plus half gt square. Again acceleration will become acceleration due to gravity. V square is equal to u square plus 2as. So here v square is equal to u square will be same, and 2gh, g and acceleration will become g or acceleration due to gravity, and displacement will again become h, height. So equations of motion for upward motion. This was for downward or free falling motion, and this is for upward against the gravity. So again we here only in 3 of them we have to put here minus minus minus. Here in 3 of them there are plus plus plus, here minus minus and minus. So this we have to put all this and this are same, only here it is plus and here it is minus. Plus and minus, this is only difference, because in this they are going upward and in this they are going downward. So let's move ahead. So now next topic is what is mass. This is important. So quantity of matter stored in an object is called its mass. The quantity of matter stored in an object, so that is called mass. Mass is denoted with small m. Mass is a scalar quantity. The SI unit of mass is kilogram or kg. This we know already. So let's move ahead. Now what is weight? We have to study now what is weight. after that we will study difference between mass and weight also. First we will study what is weight. So the force exerted by the earth on an object by which it attracts it towards itself is called the weight. Remember, weight is a force. So the force exerted by earth on an object means we are standing on a surface of earth. So the earth is pulling with a force. So that force is called weight. So weight is denoted with or by W, capital W. Weight is a vector quantity. The SI unit of weight is Newton, because the force is also measured in Newton. So weight is also a force, so it is also measured in Newton. Formula of weight. Weight is equals to mass into acceleration due to gravity. So weight is equals to mass into acceleration due to gravity, or W is equals to M into G, or W is equal to mg. So this was weight. So now let's study what is the difference between mass and weight. So the difference between mass and weight. So mass, it is the quantity of matter contained in an object. It is the force by which an object is attracted towards earth. It remains same at every point. It varies at different points. Mass will remain same everywhere, any point in the universe, but weight will differ because the acceleration due to gravity will differ everywhere. It is a scalar quantity and weight is a vector quantity. Mass of an object cannot be zero. Weight of an object can be zero, because if acceleration due to gravity is zero, then weight will be also zero. Like in vacuum, acceleration due to gravity is zero, so weight will be also there zero, but mass will be not zero. So let's move ahead. So here our chapter is completed. So let's recall all formulae given in the chapter. So first is force is equals to G m1 into m2 by r square. This is gravitational force. G is equals to G m by r square. This is acceleration due to gravity. And W is equals to mg. This is weight. So here our chapter is completed. Thank you for watching. For further chapters, please subscribe our channel and keep watching our channel Knowledge Dhara. Thank you.